Hi everyone, welcome to our podcast. And today I'm really happy to welcome Dr. Michael Kiflai, and he is a geophysicist with 10 years of experiences. Today we'll be talking about different topics of geophysics. He has worked in different domains, and we'll be picking his brain about his uh, uh, PhD to postdoc and his present work. And I'm sure this will be a very interesting podcast. Welcome, Michael. Thanks for joining the podcast.
Yeah, thank you, Tanisha, and thank you, Vishal, for having me.
No worries. So, Michael, maybe let's start with a little bit how you started your geophysical journey, and then maybe a little bit about your PhD postdoc work, and we'll deep dive into a little bit more geophysics, talk about the data and all. Yeah.
Sure, yeah, we can start with my background. So, I have my bachelor's degree from Electrical of Technology,
Mm-hmm.
and then I have my master's in geoscience and PhD in geophysics.
Uh-huh.
And my journey at the geophysics started while I was in Electrical of Technology, and I was working with the Geophysical Observatory Group, and we were
Uh-huh.
deploying seismic instruments in East Africa, Rift Valley, trying to study about the tectonic deformation. And
Mm-hmm.
we have a collaboration project between University of Cambridge and MIT
Mm-hmm.
about the seismic hazards in East Africa.
Uh-huh.
That is how my journey at the geophysics started. I was doing mainly the deep surface geophysics, but now I'm mainly focusing on near surface geophysics.
Mm-hmm. I see.
Yeah.
And what was your PhD in?
Yeah, my PhD was focusing in hydrogeophysical characterization and imaging techniques in the mangrove lakes of Everglades National Park in Florida,
Uh-huh.
and also trying to see the effect of Hurricane Irma storm surge on freshwater lanes.
Mm-hmm.
These were one of my two main research topics during my PhD study.
Okay. And what were the techniques like you were using there? What kind of data was there that you used for the study?
Yeah, so for my study mainly I was using electrical resistivity,
Mm-hmm.
electromagnetic, and groundwater data.
Mm-hmm.
So one of my research, so for example, if I'm going to explain the impact of Hurricane Irma storm surge on freshwater lanes. So
Mm-hmm.
Hurricane Irma hit uh, Florida Keys on September 2018, and we tried to see the storm surge height was greater than 2 meter, and it
Mm-hmm.
deposited saline water on the top of freshwater. So
Mm-hmm.
the research question is that how long is this freshwater is going to stay salinized?
Mm-hmm.
So I used electrical resistivity or electrical resistivity tomography techniques and EM methods
Mm-hmm.
to characterize the effect of the salt water on the freshwater lanes. So we were regularly collect data on Big Pine Key, a small island on the Florida Key, and
Yeah.
try to see the effect of the storm surge.
Ah, okay. Okay. And sorry, what exactly was the impact? Like, you can explain a little bit more
Yeah.
about, yeah.
So the impact of the storm surge was it deposited less, greater than 2 meter of a storm surge on the top of freshwater.
Mm-hmm.
And most of the plants and animals in the ecosystem depend on the thin freshwater lanes.
Mm-hmm.
And so we collected data within 2 months after the storm surge after Hurricane Irma, and then 8 months after Hurricane Irma, and 1 year and a half after Hurricane Irma.
Mm-hmm.
What we see is that the deposition of the saline water on the top of freshwater and mainly on the low elevation land.
Mm-hmm.
And with a certain amount of enough amount of precipitation and 6 months after Hurricane Irma, we see that the salinity of the freshwater lanes starts to decrease. So we start to see a recovery history. And then after a year and a half, we see 60% recovery. So the storm surge highly affected us thin freshwater lenses, and we were able to image and see the effect of Hurricane Irma on the freshwater lens.
Mm.
Yeah.
Okay. Okay. So the effect of Hurricane Irma on the freshwater. Okay, I see.
Yeah.
Okay. So that's mostly your focus. Then, what did you do for your postdoc then? Was it the same
Well, yeah,
study?
it's more or less similar techniques. And part of my PhD also, I had another research project that I conducted on the mangrove lakes of Everglades National Park.
Mm-hmm.
And the main research study was the Everglades National Park trying to change the effect of the flow of the fresh water and try to improve the quantity, the quality, the time, and the distribution of water on the southern part of the Everglades.
Mm-hmm.
And my research area was on the mangrove lakes of Everglades National Park, and I use electrical resistivity and
Mm-hmm.
EM methods, and I deploy these techniques on the lakes using kayak and small boats, and we
Mm-hmm.
collected data. And I collected data starting from 2016 to 2020, and tried to see the comprehensive Everglades National Park. They have this restoration program, and try to
Uh-huh.
see the effect of this restoration program if it makes an improvement on the surface water and groundwater. So basically, the study was mainly to see the temporal and spatial change on the surface water and groundwater.
Oh, okay. I see.
So
So I do have a question. What kind of data is this? Like if you give us a little bit idea about the data.
yeah, so with this type of data, so with the electrical resistivity, it
Uh-huh.
is a discrete data. So we selected several pilot locations where
Mm-hmm.
I conducted electrical resistivity grounding data, and in some places also we collected tomographic data. And
Mm-hmm.
in certain places also we bought a cable and we were doing a marine electrical resistivity.
Mm-hmm.
So throughout the pilot location, we had the marine electrical resistivity data.
Mm-hmm.
And when it comes to the EM method, I used a frequency domain EM instrument. And this
Yeah.
was a continuous data, and we collect every like 2 or 3 more data samples less than 1 second, and
Mm-hmm.
we measure a continuous data set.
Okay. I see.
Yeah.
Okay. So, and do you have to do a lot of pre-processing on this data, or it is okay? It
Yeah,
is.
that is the main work, especially with the frequency EM
Uh-huh.
data. We collected several data, so main task before we do the inversion and other processing technique is that you need to clean the data.
Uh-huh.
Now, as we
Uh,
always say, if you don't have a clean data, you're not going to have a clean output. And
I
you not pick certain noisy data by default, or just because you don't like one data set, you cannot remove any data set. So one of
right.
my parts of my dissertation was specifically invested a lot of time in data cleaning and try to come with a certain statistically and geophysically defendable approach to have a clean data set.
Mm.
And the instrument can have a noise in the data set, and then how can I filter the data set? So for my PhD study, I came with a compilation techniques and try to smooth the data using 50 windows interval. Like it's a
Mm.
compilation technique or smoothing techniques to filter and minimize the noise in the data set.
Uh, okay. So, okay. So there's 15 different techniques you mentioned, or okay.
A convolution, a smoothing.
Convolution. Oh, okay.
Yeah,
Wow. That's a huge part you have to
yeah,
work on. Great, great. And so maybe we can just talk like just give our audience the example of your present day work. What type of like data do you encounter in actual fields now, or what you are working right now?
yeah. So right now I'm working with the Advanced Geoscience. It's a manufacturing company for electrical resistivity, and I'm working as a geophysics and rental manager.
Uh-huh.
My main work is giving technical support for people who want to rent or purchase the instrument. I give them guidance in what type of instrument that they need to use, what type of cable that they need to use. Either it could be environmental application, or it could be
Mm-hmm.
civil power engineering related questions. geological or different kind of technique that they want to use electrical resistivity methods. So physical to give technical support. And also I manage the overall activity of the rental activities of the company.
Oh, okay. Okay, so geophysics with being manager.
Yeah, both geophysics and management.
That's really interesting. So maybe Michael, a question. So with all this data, what do you think of? Because also one of the topics we discuss here is deep learning, AI, machine learning. Where do you think is their application? Maybe in terms of your PhD thesis or the data that you were pre-processing. Where do you think there could be any application?
Yeah, so especially with when you have a continuous data set, and then one way that you are going to convert the data, they are going to invert the data and try to make a meaningful interpretation of the data set. And on this case, with big data, machine learning techniques, you can easily use or apply or train your data set to give a subsurface information. And then that is what we do, especially in geophysics. You have your data set, you are going to invert and make a reasonable interpretation of the data set.
Right.
Yeah.
So yeah, definitely then some improvements can definitely work with deep learning, machine learning. We can still apply to improve this, right?
Definitely, yeah. That is how we can apply this different techniques and improve your data quality and interpretation.
Yeah, for sure. Great. And so then coming to the kind of the last part, so maybe some opinions you have for clean energy, carbon sequestering. Well, I mean, you are not directly working in oil and gas, but as geophysicist, just a question I'm throwing.
Yeah. So during my PhD study and when I was working as a lecturer, I was teaching environmental science and hydrogeology courses. And one of the exercise that I usually give to my students is their ecological footprint.
Oh, okay.
So I give them a test so that they know about their ecological footprint and how it affects the environment and the ecosystem. So knowing that all of us are affecting the ecosystem or understanding how we affect the ecosystem gives us insight. What do we need to do to have a clean energy?
Right.
And back home, I remember that especially the use of plastic was banned like 20 years ago. When I see here, and then we are still using plastic, so that is something that we can start at the initial level and then work throughout. So I guess it is time to see for alternative source of energy to have this clean energy.
So there's definitely a need for that. Yeah.
Well, yeah, it is definitely time to look for other alternative of clean energy, starting with geothermal energy or any other clean energy that can help us to minimize our ecological footprint.
So what do you mean by ecological footprint? What exactly is it calculated there?
Yeah, so in a short way that we can say is that the amount of carbon dioxide or carbon monoxide that we release to the atmosphere. And we see our current concentration of carbon dioxide in the atmosphere is greater than 400 ppm. And if we go and increase with this kind of trend, we are going to affect our climate. So one way is we need to reduce the consumption of or the release of carbon dioxide or carbon monoxide to the atmosphere. So to do this thing is that we need to look for the other clean energy alternatives. Either it could be hydropower, geothermal, nuclear energy with some reservation that we need also to be very careful how we manage our nuclear waste.
Right. Oh, wow. Yeah, nuclear waste, right? Wow. Never thought of that. Yeah, that's really interesting. Well, I think it's very different approach, different way of thinking because all the time we were interviewing geophysicists who talked about CCS, CCU, but ecological footprint I never heard. Well, thanks for sharing that though. It's
Well, that's a little bit more toward the environmental. science approach.
Right, right. Yeah. So, thanks, Michael, for joining the podcast, and we'll be shortly posting this. Do you mind sharing your publication? Like, it's very interesting because we didn't had any hydrogeophysicist
Yeah,
in the podcast. If you can share one or two publications that we can also post on the channel, and people can know a little bit different angles on this,
yeah,
and definitely the ecological footprint is something I'll be stressing
yeah,
over there. Yeah,
yeah, sure, definitely. Yeah, I'll share with you.
yeah, sure. Uh, so thanks so much, and we'll post this shortly.
All right, thank you.
Thank you.
All right.